Hello, everyone. We were in the, we were discussing the implicit differentiation. So I like to record some examples for you. So here we go, right? We understand that we have all these rules of derivatives. And when we encounter differentiation that has to be done implicitly, it's because it's hard to solve y in terms of x completely explicitly. Take the first, take this example for, this is homework, okay? So we got x raised to the power 3 minus x times y squared, subtracting y squared, and equals to 1. Oh, actually, it's y raised to the power 3. And our target is to find the derivative of y with respect to x. So in this case, it's pretty hard to solve y for y explicitly. So we resort to implicit differentiation. In implicit differentiation, we assume, of course, x, y are related. So we assume y is the function is a function of x. Okay. So what do we assume? Obviously, this is a reasonable assumption, right? And we assume that y is a function of x. Okay, it could be a complicated situation, but it doesn't matter. They're locked in this relationship. So we're going to take a derivative on both sides. Okay, so we're going to differentiate with respect to the same variable on the same side. So the derivative with respect to x on the other side, we also take a derivative with respect to x. The derivative with respect to x, when we encounter a constant, and this is going to be 0. So on the other side, right, we got 3 terms. We differentiate each one of them according to the rule of addition subtraction of derivative. So in that case, we're going to have derivative, okay, with respect to x raised to the power 3. And we're also going to differentiate dy dx, x times y to the power 2. And then we're going to differentiate the derivative, which is y raised to the power 3. And all of it, of course, equals to 0. Noted that this piece is the product. So we're going to apply product rule on this piece and apply chain rule on that piece. And we just apply the derivative rule on this piece, which is power rule. As we mentioned that these two are, fitting for power rule. So we have 3 times x squared. Subtracting for product rule, we are going to get 2 terms, right? So here's the power rule. Okay? So we're going to have 2 terms from the power rule. So we're going to differentiate x. The derivative of x, of course, equals to 1. And we keep the y squared unchanged. And plus, and we're going to keep x unchanged, and we're going to differentiate y squared with respect to, with respect to x. We're going to differentiate y squared with respect to x. And of course, you can write this down directly because this is going to be chain rule. So subtracting on the last one, of course, is we're applying chain rule, and that's going to be we're going to write out the chain rule in more details. We're going to have d derivative y to the power 3 with respect to dy multiply. This is the application of chain rule. And in chain rule, so dy is more or less like a du, right? Equals to 0. Okay. And on this piece, we can also apply chain rule. Okay, which is going to be, this is going to be, I'll write another step. Okay, I'll write another step. So the next step, okay, 1 times y squared is y squared. So this is going to be dy squared. Okay, dy multiply, we're applying chain rule, dy dx. Okay, so dy divided by dy, that's 1, just like this one. Okay, if you have questions applying chain rules, then please ask me. Okay, now next we can more or less complete it, because here it's going to be 2y, right? And over here is going to be 3 times y squared. And in fact, right, these 2 steps, as you are getting better, these 2 steps can also be thought of as optional. Okay, you can have it, we don't have to have it. You don't have to have it. As you're getting better, you can skip those steps, and you can do, or you do it on the scratch paper. So for clarity, you get to this step, right? And on this step, we're gonna organize terms. So first, we're gonna open up the parentheses by applying the negative sign inside the parentheses. Okay, so here we come. I have the convenience to do copy and paste. So you can slow it down by when you play this video. Okay, so here I'm going to x times 2y, I'm going to write it as 2xy. And 3y squared, I can remove the dot. And here we go. Remember, our goal is to isolate dy dx. That's what we want to solve for. We want to solve for this. So these 2 terms contains dy dx. So we're going to keep it together. We're going to keep them together and move the other 2 terms. Move them to the other side, meaning we're going to subtract 3x squared. Okay, we're going to subtract 3x squared. We're going to subtract 3x squared. I'm going to plus y squared. On both sides. On both sides. We get that. Okay. So the next step, we will get this piece is equals to. Okay, so these make 0, right? And we got y squared. Oh, okay, let me just copy and paste it. Okay, it doesn't matter though. So I'm gonna put it like that. Or you can move these 2 terms to the other side. You really can do that. However, you don't really need to show your reader this piece. So I would just remove it. Okay, I'll just show it to you. And on the left-hand side, I'm going to factor out the dy dx. Okay, so I'm going to factor out the dy dx here. And after dy dx is being factored, so these 2 are out, we have 2xy. There's a negative sign in front of it, so I'm going to factor out the negative sign as well. Okay, so negative sign. and that will be 2xy, okay, plus 3y squared. Okay, so these are purely algebraic. On the other side, and of course, we're going to copy the right-hand side. I'm going to copy this right-hand side. To finish this question, we're going to divide both sides by negative of the parentheses. Okay, so the result will be dy dx, we're almost there, equals to dividing both sides by negative of the parentheses. So we have something like this. And on the top, that. This certainly looks a little awkward, right? So you can do some algebraic manipulation. What you can do is you can move this negative sign to the top, okay? Which is something like that. So you keep the parentheses, you keep the denominator, you keep the part in parentheses side, you move the negative sign to the top. Oh, sorry, to the top, and to the top get the negative sign, right? But of course, we need the parentheses in front of it, right? And this negative sign would apply to each term inside the parentheses. So we will get a nicer looking result. So negative times negative 3x squared, that's going to make a positive. And negative sign times y squared is going to be minus y squared. Okay. The final answer will be, you may like this to write the final answer right here. Okay. So that's how we have done differentiation of the implicit differentiation. Okay, so let me do another example. Okay, and this one is going to be, of course, from homework, and this is number 12. Number 12. Okay, so we got cosine x times y equals to 1 plus sine of y. And our target is still the same. Okay, so we want differentiation. We want dy dx. So the same assumption, we assume y is a function of x. Okay, so we have all these rules at our disposal. We're going to differentiate both sides. We're going to differentiate both sides. D of dx. Okay, on the left-hand side. Also, on the right-hand side, we differentiate on both sides at the same time. We do need a parenthesis here. Okay, let's look at the left-hand side. The left-hand side, we have a cosine x times y. So we're going to need to apply sine rule. Okay, so we're going to do derivative. Okay, du. So this is a cosine u. Obviously, u is x times y, right? It's the entirety of the parentheses. And then we're going to differentiate u with respect to x. But u is x times y, right? U is x times y. So we just write it this way. Okay, so chain rule is applied, and we're going to come back on the next step to do the product rule. On the right-hand side is addition, derivative, it's addition of derivative, right? So it's is with a separated derivative. So we're going to take a derivative of 1, which is 0, and then we're going to take a derivative of sine of y. Sine of y. Okay? And of course, in this case, same rule. Okay, so we have derivative sine of y, right? And we make it dy multiply. So we're applying chain rule to derivative with respect to sine of y. So here is going to be dy dx. All right, chain rule dy that makes 1. Okay. And the next step, cosine u being taken derivative with respect to u, that's going to give us negative sine of u. And the derivative of x times y, this is going to apply, we're going to apply the product rule. So of course we have product rule right next to us, which is right here, right? So we're going to differentiate x, which equals to 1, and keep the y, plus we're going to keep the x differentiating y. So dy dx. Okay, so we keep the x, I'm sorry, we differentiate x, we get 1, and y stay the same, and then we have x stay the same, and we differentiate on the y with respect to x. That's what we got, applying product rule on this part. Okay, equals to on the left hand, on the right hand side, the derivative of sine y is with respect to y is a cosine y. So that multiply dy dx. Okay, so we put a product here. Now we have dy dx on both sides, and we need to bring them together. So the derivative part is done, and the next part is algebra. Okay, and of course we may like to just replace the u by xy. Okay, replace u by xy. So this is the result from the derivative part. And next, and of course you can simplify. And 1 times y, you can simplify on the next step, even though it's not really that necessary, right? But we're going to distribute. We're going to distribute negative sine of xy with y, and we're going to write it this way. We're going to write it. We write a y in front of it. Okay, it's a negative y. I'm going to explain to you why. Right? We must write it this way. Okay, so that's sine of x times y. If you write y behind, okay, if you write y behind, it could be a little bit confusing because people may question, are these going to be together being signed or not? So it's better we put it y in the front. Okay, these are typical conventions that we must pay attention to increase the clarity of our work. The next one is we're going to take a negative sine x of y, multiply x. So that's going to give us negative. For the same reason, we put x in front of it, sine xy, and then dy dx. Okay, dy dx. On the other side, we just copy. All right. By this time, we see we have our target dy dx is on both sides. So we're going to move them together. Do that, and this part doesn't contain dy dx, so that's going to be separated with the part with dy dx. So to do that, we're going to use our algebraic rule. right? We're going to add term on both sides. We're going to add this term on both sides. Okay, so we're adding this on both sides. Okay. After adding them on both sides, of course, the next step we will just only have this piece equals to, okay, that piece adding that piece, and we're gonna factor out the dy dx, right? So we're gonna factor out the dy dx. So it's gonna get, we're gonna get to this piece, this kind of two terms in the parentheses, which is a cosine y multiply x times sine times a sine of xy. And we may like to put a bracket, okay, for clarity. However, as I was just showing you this work, your reader usually don't need to see this. Okay, I'm just showing you this, but I'm gonna delete it. I don't need to see this, just to keep it nice and clean. Okay, maybe leave some space between the lines to make it easier for the reader to read. Okay, always do your best work. So next, we're going to divide both sides by everything in the bracket. So dy dx is going to equals to everything in the bracket. So we can actually drop the bracket. Okay, we don't really need the bracket right now. If we put it under, on the end, the numerator is going to be that. That's finished. That's done. Okay, that is finished. All right. So that's another question. And let's look at number 14. Number 14. Okay, number 14. Number 14, which is another example, we have e to the power of y sine x equals to x plus x times y. And of course, once again, we want dy dx. So wanted dy dx. We have all these derivative, rules next to us for our convenience. And we're going to differentiate both sides with respect to the same variable, x. So the left-hand side is taken derivative. It has two terms in product, so we're going to put them in parentheses. Equals to the other side, derivative with respect to x, and that's product is going to be inside the parentheses. Okay, both parentheses are necessary. With some, discussion about maybe the first one is not, but let's have them to clarify that, So we have on the left-hand side, we're going to apply product rule. Okay, product rule. And the product rule is right here. Okay. So on product rule, we will, you can make your choice. Okay, so derivative, suppose we differentiate e to the power y first. Okay, and not differentiating sine x. So we're gonna have two terms, right? If we differentiating e to the power y and keeping the x, and you should write a sign of x in the front of it. Okay, otherwise it could be viewed very confusingly. Okay, if you keep it here, right? it's actually confusing. Are you differentiating with just e to the power y, or you also differentiate e to the power y times sine x? So to clarify that, I'm going to put it in the front. Okay? Plus, I'm going to keep the e to the power y, and then differentiating sine x. The derivative of sine x is just cosine x, we can just put it there. And we'll come back to deal with this part, with apply chain rule. But let's look at the right-hand side. The right-hand side, we're going to differentiate x with respect to x. That's going to be 1. Plus, we're going to differentiating a product. And this product is x times y. Okay, it's x times y. So you can actually apply product rule here if you wish. Okay, let's see what we're getting. If we apply the product rule, right, we're going to get 2 terms. Right, we're going to get 2 terms. Let's do the next step. Okay. So I usually show more lines of work than necessary. So when you show your work, as long as it's nice and clear, and you yourself can follow, you can skip a line or 2, but make sure you can follow your own work, okay? And with the clarity, Now we're gonna still hand side, right? This part is already finished. Okay, I'm going to copy this, paste it here, right? So that's equal sign, and we're gonna take care of this part. And over here, I can just drop the dot, so this part is done. And here, we're gonna apply the chain rule. So we're gonna have dy to the power y multiply dy dx. Okay, so let me write it down this way so we can see better. But differentiating e to the power y with respect to x, according to chain rule, we can change it to derivative with respect to e to the power y with respect to y. Okay, this is more or less like e to the power u du dx, right? Here we just use the y. And e to the power y with respect, derivative of e to the power y, differentiated with respect to y, that's just e to the power y. Okay. Now, we'll come back to it. On 1 plus product rule. Do we need a bracket? We don't really need a bracket, but we should expect 2 terms. We've done this before, right? The derivative of x times y. We've done this before, right? So it's something like this. Okay, it's something like this. So let's do it again. So we take derivative of x with respect to x. That's going to be 1. We keep the y plus we keep the x, and then we take a derivative with respect to x. So that's it. And organize it a little bit. Okay, we can get rid of some of the dots. For example, I can get rid of this 1 times y, 1 dot times y. Over here, I want to remove the dot. I can remove the dot. But if I remove this dot, that could cause confusion. Okay, so I'm going to bring this e to the power y to the front of it. And this is a clearer. Okay? So these are the little details I wish you guys to know. Okay, so you don't want to have too many dots. You don't want to have too many parentheses, but you want to have just enough. It's clear. So our goal is to solve for dy dx. And we have 2 terms here, and they have dy dx. We're going to bring them together. How do we bring them together algebraically? Well, we're going to subtract x times dy dx. Okay? And this piece, we're going to subtract that piece as well. Okay, so we're going to subtract this piece as well. Subtracting that piece on both sides. Okay, so we subtract this on one side, and we're going to subtract that on the other side as well. Right? And we subtract this piece on this side, we're also going to subtract the same piece on the other side. There. Subtract the same thing on both sides. Mathematical principle number 3, right? Adding, subtracting the same thing on both sides of the equation. So subtracting the same thing on both sides. Subtracting the same thing on both sides. And the consequence on the left-hand side, right? So once again, we're going to factor out the dy dx. So dy dx is factored out. And this piece, subtracting x, right? Subtracting x. On the right-hand side, on the right-hand side, well, these two make 0, right? These two make 0. And these two makes 0. So the right-hand side, we just have 1 plus y minus that piece. After all of this is done, right, and you don't have to do it explicitly, I would recommend just clean this up. Okay? All right. The algebra part. And next, we're going to divide both sides by the entirety in the entire thing in parentheses. So we're going to get a numerator on here, denominator, which is over here, and we can remove the parentheses, and we are finished. We're finished. So that's the implicit differentiation. I think this is number 14, right? So let's work on number 16. Well, I don't know how long this is now, but you guys can manage to you know, just take a pause, okay? Take a break if you need to. All right. Y dx is also wanted here in this question. And we have number 16, right? We have x times y on one side, and the other side is the square root of x squared plus y squared. Okay? The same idea, we're going to differentiate on both sides, right? On both sides, we differentiate them at the same time. So x times y, I'm going to put them in parentheses, and that equals to the derivative. Okay, the derivative of the square root of x squared plus y squared. And we don't need the parentheses on the right side. Okay. Product rule, right? The derivative of x times y. By this time, I think we're pretty familiar with it. So we're differentiating the x equals to 1 times y plus, we keep the x, and then we get dy dx. Equals to, on the right-hand side, we need to use same rule. Okay, so we can see the entirety of the square root, anything x squared plus y as u. So we're gonna write it down as the derivative of square root of u. You can go direct, okay? U, oops, multiply, okay, du dx. All right. Obviously, u is x squared plus y squared. So we're going to replace u by x squared plus y squared. Next step. Okay, 1 times y, we can remove the 1 times. It's the same thing. The derivative of square root of u with respect to u is 2 times square root of u under 1, right? By this time, we can substitute the x squared, y squared. We can substitute u by, oops. We can substitute x squared plus y squared into u. Okay, so that part is done. And then we'll have to work on this addition. And of course, we're going to apply addition rule. The derivative, so we have it here, right? So we're going to generate some terms. We're going to generate at least 2 terms, okay? I think there will be 2 terms, actually, 2 terms. The derivative of x squared with respect to x, that's 2x. And then the derivative of y squared with respect to x. We're going to apply chain rule again. We're going to apply chain rule again. So how does it work? Right? We're already pretty familiar with it. So I'm going to just do it here. So dy. So that's going to be dy dx. Okay, so that's when we differentiate y squared with respect to x. We use chain rule, we apply, we get that. Now, we get dy dx on both sides, and on the right side, we have this, you know, bracket, right? So over here, let's do the 2 times y, okay? And then what? If you notice, there's a 2 here, there's a 2 here. I can factor out the 2 and bring the 2 out, and this 2 will take away this 2. So that will make our life a little bit easier. But we still have this, you know, denominator here. So to make life a little bit simpler, I'm going to multiply both sides by the square root of x squared plus y squared. So we're going to multiply this piece with that piece, with that piece, and of course with this piece. So we multiply both sides by the square root of x squared plus y squared. But this dot is really not necessary. I just want to leave some space. And this dot is not really necessary. And this dot is not really necessary. I'm just describing to you that's a product. And these dots are not really necessary. But now if we reduce it, if we reduce after this product, right? This keep the same, this stay the same. And on this side, it's 1. Right? And this 1 can be removed. And the bracket can be removed. So now we got dy dx on both sides. We got dy dx on both sides. We need to bring them together. We need to bring them together. If we bring this dy dx to the other side, we're going to subtract that guy, right? Because it contains dy dx. We're going to subtract the same thing on both sides. We're going to subtract the same thing on both sides. And we're going to subtract this piece on both sides as well. Okay, so I'm going to subtract that term on both sides. Okay, we're subtracting this piece on both sides. Hold on, I'm going to move this over, subtracting that. Okay, so subtracting the same thing on both sides. Okay, if that's clear to you. This subtraction will bring us, because these two are opposite, that's 0, right? And so the left-hand side will have a dy dx, and this term has dy dx, and this other term has dy dx, so we can factor out the dy dx. Oops. Inside the parentheses, we got this factor from the first one, subtract y, which is from here, right? And then these two, of course, make 0. You already know that. Equals to the right-hand side, and these two are opposite, that's 0. We just have x subtracting y times the square root of x squared plus y squared. After all this is done, I really recommend you not to keep this, or you do this whole thing on a scratch paper. You don't want to make it look so messy. Delete it. Okay, of course, it's easy for me to do it, but keep it clean. Keep it clean. That's my recommendation. If you insist to leave it there, of course, your reader has just have to read it. Make sure there's nothing wrong. All right. So next, dividing both sides by the parentheses. Okay, so dy dx equals to the right-hand side is going to the numerator. The left-hand side is the entirety of the parentheses goes under. And by this time, the inside, well, under the, you know, as a denominator, we can remove the parentheses. That will be okay. And we're done. We're finished. Okay. Is there anything fancy we can do? Okay, there's anything fancy we can do? Yes. In this case, we can actually do something fancier because we were given this equation. Basically, we are told, okay, so this was given. This was given. From this given, we know that the square root of x times x squared plus y squared is the same as xy. So what we can do is that we can substitute the square root of x squared plus y squared by its equal, because it's assumed to be equal. So we're going to replace this by that, replace this by that. So it's a much simpler result. And so then we organize our terms. Let's see what we get. And here we got x minus x times y squared. And over here, we got x squared times y minus y. Can we reduce it even more? We can try it. We can try it. Okay, for example, we can factor out the x on the top, which is going to have 1 minus y squared left. And you can mobilize your algebra, the algebra in you. Okay, and the other one is you factor out the y, and you get x squared minus 1. No common factors, nothing in common. So what are we going to show as the result? All right, let's see. So the result, okay, I'm going to show you a couple of forms. You can show this as final answer. You can show this as final answer, or this one as final answer. Either one is okay. Either one is okay. You can see sometimes you need to go back to look at the equation given, okay? To look at the equation given and simplify your result a bit more, okay? So we're gonna do one last one. And this one, because I don't want to make this too long, okay? Number 20, okay? Same task. We want to differentiate, we want to find dy dx. So that's wanted, right? And the equation we were given is tangent. Whoops. Oh, this software has two modes. Tangent x minus y equals to y over 1 plus x squared. We got to use the quotient rule. Yay. All right. Derivative on tangent x minus y equals to derivative on the other side. We do this at the same time. Okay, no parentheses needed on the right side, and no parentheses is needed on the left side. No need. All right, so let's look at the left-hand side. On the left-hand side, we're gonna take a derivative of a tangent. We're gonna view this as a tangent. Of course, u is going to be x minus y. So du, so we're applying same rule right here. So du dx. And I'm going to replace my u with x minus y. Okay? And we're going to come back to take care of tangent u with respect to u, which is of course secant square u. Okay? On the right-hand side, we're going to apply quotient rule. Quotient rule, where's the quotient rule? Quotient rule is right here. Okay, quotient rule. So we have 1 plus x squared differentiating y, right? That's going to give us dy dx, but the denominator is going to be kept, right? 1 plus x squared. Subtracting y is kept, and we're going to differentiate 1 plus x squared. 1 plus x squared derivative of 1 plus x squared is going to be 2 times x. Now, okay, so let's look at the left-hand side. Left-hand side, we're going to get secant square u. Okay, multiply, and we're going to apply the difference of derivative, right? So this is going to give us the derivative of x is 1, subtracting, and that's dy dx. We might just replace u by x minus y here. So left-hand side is finished by this time, the derivative part. Let's look at the right-hand side. The right-hand side, we're going to keep the denominator. The numerator, we have a dy dx in numerator, so we're going to copy that. And subtracting 2 times xy. Ha, look at that. We got dy dx here, we got dy dx here. How do we bring them together? Well, and we also have a denominator here. So let's do it one at a time. First, we want to get rid of the denominator. How do we get rid of the denominator? Well, multiply both sides by the entirety of the denominator. So we're going to multiply this piece on both sides. I'm going to multiply that on this side too. Okay? We multiply the same thing on both sides, and that same thing is not 0 for sure. And on the right-hand side, this piece, take away that piece because they're the same. The right-hand side will be left with the entirety of the numerator. Next, we still have dy dx on separate sides. That's okay, okay? And for clarity, we can actually put this to the front, in front of secant. Okay, this is really just for clarity. So we take the whole of it. This is the whole of it. Multiply 1, and we take the whole of it, multiply negative dy dx. Okay, so we're going to take the whole of it, multiply 1, subtracting the whole of it, multiply dy dx. That's equal to, on the right-hand side, we do nothing. We do nothing. Okay, so now I can remove this times 1 for simplicity. Of course, this looks a bit more complicated, but that's, we need to work this out algebraically. Dy dx on both sides. So what I'm going to do is I'm going to move dy dx to the right side and 2xy to the left-hand side. To do that, I'm going to take the whole of it, right? And here, this is subtracting. So I'm going to we're going to add this on both sides. We're going to add this on both sides. After adding this on both sides, this time I'm going to do it in 2 separate steps. Okay, because this is otherwise is gonna too messy. I'm adding this. The result of adding this, I'll only have this piece left on the left-hand side because these 2 pieces make 0, right? On the right-hand side, this piece has dy dx and that piece has dy dx. So I have a dy dx factored out. But I still have this minus 2xy though, okay? Don't forget that. Because I haven't added 2 sides with 2xy, okay? We're going to do that on the next step. So dy, this term and the next term, dy dx is factored out. So on here is 1 plus x squared plus the whole of it in here. And of course, we're going to add 2 times xy on both sides. I think I don't need to show it to you. You get it, right? So this piece is added to the other side, 2xy. After all is done, we don't really need to see this, okay? Almost done. So now dy dx is equal to the entirety of the bracket will be dividing both sides. Dividing to both sides. The bracket can be removed. The entirety of the right, the left-hand side will goes to the numerator. And that's almost done. That's almost done. So we're going to examine if anything can be simplified from this given. Okay, that was given. Anything can be reduced. Is there anything we can do to reduce it? You know, I don't think so. I don't think so. So just forget about it. Forget about it. So this is done. This is done. As we have gone over all these examples, thank you for watching. I hope that you've done this along the video so you can pause and replay and so on and so forth. Thank you for watching.